Recording, okay, and I'm going to talk to you about polynomial and rational functions. Do you know about polynomial and rational functions?
Yes.
Good. Hey, so a polynomial function is one defined by this long ugly thing. Please don't write that down, okay? Polynomial functions are just ones that have they have exponents that are whole numbers, and they have coefficients usually that are whole numbers, like that's writing kind of wide. Okay, I change that. So they have exponents like you could have like 2x to the fifth plus 3x to the fourth minus 3x plus 2 or something like that. F of x is equal to, that's a polynomial function. Okay, so this section is all about polynomials, but we're just going to talk about quadratics. Polynomials, generally when we graph them, they're smooth. They don't have any like any sharp edges in them. They don't have any discontinuities. A discontinuity means it does something like this. They don't do that. They don't have any sharp peaks like that, and they're functions. And so usually they always will have positive integer exponents, and they'll have coefficients. You can't have a fractional coefficient, but we usually won't be dealing with those, at least in this chapter. So this is a polynomial of degree 5 because you take the highest degree term of the polynomial, and that's the degree of the polynomial. We'll get to a thing later on in the chapter when we talk about the fundamental theorem of algebra, which says if the degree is 5, the most times it could cross the x-axis is how many times? 5. But it could also cross less, then it could cross more and stuff like that. But if it's degree 2, how many solutions could you possibly have? 2, right? And so degree 1, how many solutions could you possibly have? 1, right? That's a polynomial of degree 1. Also known as a linear function, okay? So, all right, so that's kind of the general formula of, you okay there, Hal? Yeah. Okay, good. All right, so now we're going to talk about, what are we going to talk about? Quadratic functions, okay? Quadratic functions are functions of the form ax squared plus bx plus c. In the book, they call this the general form of a quadratic function. This is called general form. General form. Okay? General form, and I've always called that standard form, but in the book they call this general form. And what shape do quadratic functions make? You guys know.
U.
They make U's, also known as parabolas. Okay? And then some things that you got to know about parabolas. Okay, what's on the next page? Did I hit? Let's see what happens. Boom, boom. Teacher notes. Okay, so here's, this is where I get to say stuff. Hey, do you know what a polynomial is?
No.
It's when your parrot doesn't get any lunch. Y equals y polynomial. Okay, so if you have a polynomial function like this, a does something to it. Anyone know what a does to your polynomial function? It stretches it. So if you have like y equals 2x squared compared to y equals x squared, is that going to be fatter or skinnier? Y equals, so that's going to make it skinnier. Okay, that makes it skinnier. Skinny, okay? And then if you put like a number less than 1 in front of it, what if I put y equals negative 1/2 x squared? What's that going to look like?
Flip over the y-axis and get fatter.
Yeah, it's going to flip this way. It's going to make it go upside down, and it's going to make it get fatter, right? So this makes it wider, I guess. It's also called a vertical compression, okay? So if the absolute value of A is less than 1, it's a sorry, that's wrong. It's a it gets wider. Okay, they call it a compression, but some people get confused by that. if the absolute value of A is greater than 1, it gets skinny, okay? Skinnier. Skinnier. You know that already. You know that already?
Yes.
Yes. Okay. Yep. You know who didn't know that? You can play with it. There you go. Okay. What else? The domain. Okay. Let me get one more page of before we start. Domain. Okay. Of a quadratic function is what values can I plug in for x into the general form y equals ax squared plus bx, okay? Bx, sorry, plus c. What value, what, all real numbers. So you could write like x, how do they do it again? They do like this, then they go like this, and they do x is all real numbers. They do that kind of symbol like that. So it means x is all real numbers. That's what that means. Okay. How about y? How about the range? How about the range?
It's going to be the y value.
It depends. Yeah, it depends on. It depends, right? So if I have a quadratic function like y equals x squared, what's the range of this? What's the range of that quadratic function? I know. What's? Yeah, y is got to be greater than or equal to 0, right? So if it's like here, y is greater than or equal to 0, it's going upside down. But it depends on where the vertex is. Okay. You have an axis of symmetry. Do you know about the axis of symmetry?
Yeah.
Who can tell me what the axis of symmetry is?
It cuts the parabola in
It
half.
cuts it in half. It has an equation, okay? X equals negative b over 2a. So if this is the general form of the quadratic function, the way you find the axis of symmetry is x equals negative b over 2a. And the way you find the vertex is,
F of negative b over 2a.
right, you plug it in. Okay, so the vertex for any parabola in general form is given by x is negative b over 2a, and y is f of negative b over 2a. In other words, just what Morgan just said, you just plug it into your, you just plug whatever you get for x in and into the equation and you get out y. Did you know that? Who knew that? You knew that. You knew that? Okay. So now I think I'm ready to start my next cutting edge PowerPoint. Okay. Teacher notes, I already did that. Ah! Oh, I just wrote that. Okay. So find the vertex of this parabola and sketch the graph. Okay. So what's x? Where's the? Let's first find the axis of symmetry. X equals what?
Negative b over 2a.
So what's negative b over 2a?
It's going to be 4 over...
Negative 4 over negative 4, which is equal to...
Negative 1.
Oh, it is, isn't it? That's equal to negative 1. So x equals negative 1, that's the axis of symmetry. And then to find f of negative 1, okay, I plug that in there and I get negative 2 times, don't forget to take this and then square it. Don't multiply it by the negative 2 first and then square it. First you square it and then you multiply by negative 2. Then you multiply negative 4 times, also times negative 1, and then you add 1 to it. And what do I get out when I do that?
3.
Is that 3? I think that's 3, right? Negative 2 plus 4 is 2 plus 1 makes 3. So what that means is I have a vertex. So now I'm going to try to graph it. Let's put some arrows on the end for our viewing audience at home. Okay, there's arrows, arrows. Oh, that's bad. That's good enough. Okay. So what I'm going to do is I'm going to plot the vertex, negative 1, comma 3, right? So we're going to pretend that this is a very accurate graph. So there's negative 1, 3, okay? the axis of symmetry, I'm going to make that dotted. We're going to make it different color. Goes like this, through x equals -1. Let's see if I can do that. Oh, I tried to make it a different color, but I didn't do a very good job. So, but then you can't, which way is this parabola going? Right side up or upside down?
What?
Is it right side up or upside down?
Going like this.
It's upside down because it's got a negative in front, okay? How could I find another, so this is the vertex, I know that this is the vertex. How could I find another point on that parabola? What would be a good point to plug in? 0 is always a nice point to plug in. So that will give you the y-intercept. So f of 0 is 1. Okay, so that means that there's a point here. And then I can use symmetry to find another point, right? That's what's good, the axis of symmetry is good for. If you know a couple points on one side, then you could plot points on the other side. And I could find that point, and then I can sketch in a perfect parabola. Come on. Is pink gonna work? Pink's gonna work. There it is. Okay. Whoops, that's a really bad parabola. How would I find this point or this point? How would I find those points if I want to find them? Also known as the x-intercepts, Calvin.
Plug 0 in for x.
Plug 0 in for x. No, not
Plug 0 in
for
y.
0 y. So if I wanted to find those 2 points, I would have to plug those in, right? And either factor it or use quadratic formula. And I'm not sure what those points are in this case, but they will ask you on your homework, find the x-intercept. So then you have to either factor it or solve using quadratic formula, not matrices. No. All right, we got that? Too much talking? Let's move on. What's next? Uh-oh. So, this is called standard form, okay? I've always called this vertex form. Have you guys seen this before?
Yeah.
Yes, okay. So the standard form of the equation, so find it, so if you have a equation that looks like this, just for example, y equals -3x minus 2 squared plus 5, right? That's the equation of an upside down parabola with a vertical stretch of 3, right? And shifted which way? Where's the vertex?
It's to the right 2.
It's the right 2 and up 5, right? So if I were going to, just real quick, they'll say, okay, sketch this parabola. So you go to the right 2, because it's x minus h. So h, if it's minus, h is positive, right? But if this is minus, it goes down. But in this case, k is positive, so it goes through -2, 5, right? It's a vertex. I'm not going to sketch the whole thing. And it's upside down, and it's got a steep stretch, right? So it's going to look something like that. Just really rough. I'm not sure what the y-intercept is, but I can find it. Now what if I want to do this one? How would I do that?
Oh,
So-
you plug in the vertex into the vertex.
Right, so you, in this one you go kind of backwards, okay? So you say y equals, I don't know what a is yet, but I do know that y equals a times x minus h. What's h in this case?
Would be -1.
It'd just be 1, right? So x minus 1 squared plus what?
Plus -2.
-2. Okay, so it's -2. So that would be the equation of parabola, except I want to find out what a is. How do I find out what a is? Yes, young man with your hand up in the back.
I got you later. You just plug in the point.
You plug in the 0.36. So people get very confused by this. They say, how do I find a? Okay, you just got to plug in that. You have to be given another point. So I'm going to plug in 3 for x and 6 for y, right? And solve it for a. So I get 6 is equal to a times 3 minus 1 makes 2, right? 2 squared, so that's 2 squared minus 2, minus 2, I wrote 4, sorry. Just thinking ahead. So you get, did I do that wrong? No, I did that right. So I get 6 is equal to 4a minus 2a equals 4a equals 8, a equals 2, right? So now I could rewrite my equation, y equals 2x minus 1 squared minus 2, which, and if you think about it, I try to sketch to kind of think what these things will look like. It does say sketch, doesn't it? Right then, I pass it through the point. So 1 down to, there's the vertex. If it passes through 3, 6, got to be going uphill, right? So that's a really bad, I really missed it, but something like that. Okay? Questions? Okay. We have to pause for station identification. They have a little more trouble, okay? So you should pay attention to this. Here how do I change from this form into vertex form? You guys know?
Find the vertex.
How do you, well, you can't just, I guess you could find the vertex. That would be a lot of work though. You could plug into negative b over 2a and then do it that way, but what's another way to do it? No, guess and check doesn't work either. Factor doesn't work either. Yes? You have to complete the square, okay?
I got it.
Completing the square. So I don't know if you guys remember completing the square, but basically what you want to do, you want to write this as y equals x minus, x minus, you take this, you take b, and you divide it by 2, okay? So 2 quantity squared, and then you add or subtract. I'm going to put this minus 5 over here, and then I have to do something right here, and I have to figure out what goes here. It's either a plus something or a minus something. Anyone know what that plus or minus is?
Oh, is it?
25.
Is it 4?
4.
It's 4. Do I subtract the 4 or do I add the 4? I subtract it, okay? Why do I subtract it? Because if I were to FOIL this, I get x squared. If I FOIL this, right, I get x squared minus 4x plus 4, right?
Right.
So when I rewrote this part of it as this, I've added 4. I've added, messed up, right? No, I didn't. So I need to subtract 4 to keep my equation the same. So then I keep going. So I get y is equal to x minus 2 quantity squared minus 5, okay? And then you've completed the square and you're good. You guys stop, all right? Done? Done?
Are we done?
Where would
No,
A-
we're not
where-
done.
Where would A go?
Where would A go? In this case, A is 1.
Yeah, I know, but if it wasn't 1, I'm saying. Like,
We're going to do one like that in a minute,
okay.
okay?
Good job, Alex.
Good question, though. Okay, so now we're going to do one that has a coefficient in front of the x squared. So this is where it gets kind of tricky, and so I would move this up here, but this thing for some reason doesn't work. I don't know why that doesn't work, but it doesn't. So, but in any case, what you want to do? Anyone know what you do?
Oh, don't you factor out the 2?
Very good. Very good. Hey,
Very
Tyson.
good, Tyson.
Tyson knows. So I get F. What's it doing now? Let's go back to normal.
It's actually really good. It's a good color.
I don't know what I did now. Is it working now? There, it's working. So, so what I want to do is take out a 2. So y f of x. But I only want to take that 2 out of the first 2 terms. So negative 2. I know you can factor out an x also, but you don't want to do that. You just want to factor out the negative 2x squared minus what?
What did he
Very
Plus what?
2.
Correct.
2x plus 1, okay? And now I complete the square on this part, okay? So I get negative 2, take half of the b term. So what's that?
1.
X plus 1 quantity squared. Then you're going to add or subtract something, and you're going to have a plus or 1. Who can tell me what I'm going to add or subtract over there?
Minus 1.
Minus 2?
Now-
No, minus 1.
You're going to add 2, okay? Do you know why we add 2? Why do we add 2?
Because when you multiply that negative 2 back in, it's
Right.
gonna be negative 2.
Because if I FOIL this, I get a 1 squared. and I'm multiplying by -2. So when I rewrote this as this, I've added a -2, so I have to add a +2 to keep it balanced, okay? So finally, I rewrite it as -2 x plus 1 quantity squared plus 3 would give you the equation of that particular graph. Do you guys understand that question? I think one more problem and then we're done. Okay? I'd have you guys practice one, but I want to get through the video and I want to give you a chance to
Am I
get
gonna be on
started.
YouTube?
What?
You're a star, dude.
Yes, you're a star. We're gonna rate you on IMBD, whatever.
Can I
it's
talk
called.
myself?
No. Oh! Shh. I haven't talked about this. So minimum value, okay? So on a parabola, you could have both a minimum value and a maximum value. So if I were going to graph this one, it goes through 4, right? 5, right? So this is 4, 5. What's the minimum value? The minimum value is just 5, okay? It's just the y coordinate of the vertex. So the minimum value is 5. If the parabola is going upside down, this is called a maximum value up here, right? Minimum, maximum, relative maximum. They use those words, okay? So just, and then the next slide kind of shows you, this is really complicated for what it's saying, okay? All this is saying is that you have a minimum if it's a right side up parabola, and the minimum is the y coordinate of the vertex. And then it's saying, let me put a dot on here so it's recording my notes as well, okay? So this says that if it's a right side up parabola, the minimum value is the y coordinate of the vertex. And if it's a upside down parabola where a is less than 0, then the maximum value is the y coordinate of the vertex. All right? That's all that's saying. Do you need to copy that down? You don't need to copy it. You need to have on
Do you want me to bang on the drum machine later?
I want you to stop copying. And you're just encouraging those who don't over there. Okay, they have a sub today, so.
Oh, that explains a lot.
That's where they're being abused.
Okay, they're being more rude than usual. All right, so I'm gonna just last problem, and then it froze. Last one. So this is fun because this is a baseball problem. Okay.
I said.
So baseball is hit at a point 3 feet above the ground. So there are lots of applications of parabolas. One of them is with projectile motion, like this problem. Okay. So if you're at Coors Field, okay, and here's the baseball player. He's doesn't have arrows on the end. Here he is. Here's the baseball player. Hits the ball, and it from a height of it says 3 feet above the ground. Okay, and it says with an initial velocity of 100 feet per second. The general formula is, we'll talk about the general formula later on, but this number, who knows where this number comes from? Anyone know where that -0.032x? That's the acceleration due to gravity, right? So that's the force with which it's being pulled down.
No.
But so 32 feet per second. It is 32 feet per second, right?
Okay.
So it's so this is like negative. It's the ball is being launched up this way, so it's got an initial velocity of 100 feet per second. So somehow that's factored in here, and 3 is the initial height. You don't need to know all that at this point. All you need to know is the path of baseball is given by the function. What is the maximum height reached by the ball? So basically, what am I looking for?
Negative d over 2a.
I'm looking for f of negative d over 2a, right? So I have to find this point right here. So I need to first go negative b, which is -1 over 2 times -0.0032, okay? And I already did this on my calculator, and I think I got 156.25 feet, okay? You know how to put that in your calculator, right? Then, how do I find out how high the ball goes?
You plug that into the.
I take that and I plug it into the original equation for x, right? So let's just do that since we're live here and show our studio audience how good we are with our calculator.
What's up there?
So what I'm going to do, first you have to go y equals, okay? And you have to plug that equation in, okay? Where is it? Y equals negative 0.0032x, whoops, 32, delete x squared.
You're putting that in the
I'm putting that in the exponent. Come on. You can do it.
Mr. Leader,
What?
how did you get the calculator on your computer screen?
You have to pay for it.
How much?
I don't know. Okay. X squared minus plus. Thank you, Jack.
No problem.
Plus x plus 3. Okay? Couple different ways to do this. Okay? You can go, so now I got it in there. I can go vars. I can go, well, let's set it up as a window. If this is 156.25, how far do you think it's going to go about?
156.25.
Well, how far until it hits the ground again?
Oh,
A little bit more than that, right? Because it's going to start at a point and it's going to keep going. So let's plug in an X. Let's go to window and set it up as 0 up to about 400. Is that a good guess?
Yeah.
Okay. And now how high do you think the ball is going to go?
probably like 300.
Probably, let's set it to 200 and see what happens. Okay. So if I hit graph, let's see what we get. Oh, there goes my baseball player. He's shooting it. There it goes. And it's going to land. Isn't that cool? Okay. So a couple different ways you could find out how high it goes. You could go second calc, which is above trace. And you could go maximum 4. And it'll say left bound. You go over to the left. You hit enter, right? And it'll say right bound. Have you guys done this before?
Yes.
Right bound, you hit enter, and then it'll say guess, and you guess somewhere in between, and 156.25, comma 81.125 feet. That's how high it goes. The other way you can do it, there's a couple different ways. You can go to your, if I go like this, if I just want to plug it into the equation and don't worry about graphing it, vars, y bars, function, y1, and then in parentheses you put in your value, 156.25, and that will do the math for you and get 81.125. You want to see one more way?
No.
One more way. Second table set, you set your table to ask, okay? You set your table to ask, okay? And then if you go second table, okay, all you have to do is plug in 156.25 over here, and it'll give you the answer in your table, 81.125. So a bunch of different ways to do the same thing. Okay, and remember, you've heard it here. Wait, we're not done yet.
We didn't interject.
Remember, that's your homework, and that you have heard it here on Mr. Leader. Whoops, sorry.
With jokes with Kenny.
Wait. Hey, come on, I'm doing. You've heard it here on Mr. Leader's Math Channel. Okay. Where's my power?
Subscribe and like, don't forget.
What?